So let's take this expression. Given f of a, comma, b, comma, c, comma, d, 4 variable, equals the summation of the minterms, that's when the function is going to be 1, as 0, 2, 3, 7, 8, 9, 13, 15. It also has a couple of don't care. Don't care at 1 or 12. What does that mean, don't care at 1 and 12? I don't care if you make it 1 or 0. So what are we going to do is put it to our advantage. I'll make it 1 if it help me simplify that expression. I'll make it, if I'm looking for the minterms, if I'm looking for the max term, I'll make it 0 if it helps me reduce that expression. So let's see, this is a 4 variable K-map, A, B, C, D. In case you forgot, I put the most significant on the top, the least significant on the bottom. A, B, C, D. 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. I'm going to label these, write the numbers on them. This is location, so you'll know I don't have to keep looking. 0, 1, 2, 3. Can you see the numbering? Yep. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. It says we have a 1 where? At 0, at 2, at 3, at 7, at 8, 9, 13, and 15. 0, 2, 3, 7, 8, 9, 13, 15. At don't care, we have 1 at 1, 1 at 12. Don't care. There's 1. Let's put X for don't care. And at 12, which is right here. Notice this one. I can group it with this and I can group it with that one. See that? So the rest, by the way, are zeros.
You can do 4 in the corner.
Right there?
Yep. And then do 4 vertically on the left.
Yep, I could.
And then the 2 in the middle.
I could. Yep, that will work out well. I'm just looking if that's the best move, because one of the things I was looking at first, you know, I can maybe take these 4 together. That will eliminate that. Then I can take this and take this, but that still leaves this one. I'm going to have 4 terms. But if I take this here together, and this group together, because the don't care, I can make it 1 here if that helps me. I covered all of these, and I can take these 2 together. That's 3 terms when you write it. If I decide to break it differently, I'm probably not going to end up with 3, maybe with 4 terms. So in this case, if I read this one, notice C and D is changing, that's gone. A and B are zeros, that's A naught, B naught. This one, the group of 4. D did change. Oh, somebody's birthday. B is changing, so A is 1, C is 0. A is 1, that's why it's not complemented. C didn't change, that's a 0, that's why it's complemented. Now let's look at these 2 here. And that'll give me what?
B.
So B is 1, that's good. C is 1, D is 1. I just simplified that. If I'm looking to group the zeros really not much of a choice again, because for the zeros, I gotta take these zeros, maybe these two zeros, and these two zeros. So if I group these zeros, notice here, A is 0, B is 1. So 0 is good, B I gotta complement that, and C is 0. That's this one. This one will be what? B is 1, that's B naught. C is 1, that's C naught. D is 0, leave it alone. And for these two, A is 1, complemented. B is 0, leave it alone. And what? C is 1, complement that. So when you look at it, if you were to build this in the lab, which one will be easier to build? Well, this one at least has 2 input versus 3 input. More wiring right there, just to connect the gates. 3 input, 3 input, 3 input, 3 input. 2, 2, 3, and 3. So I got 2 less wires. Time. Wiring costs money. Not that much money, but still costs money. You got to connect them. That's labor. You got to worry about something breaking in them too. So that would be my choice here versus this one. Let's try the other one. I have a few of them written down. I don't like W, X, Y, and Z, so I'll make them all A, B, C. It is the summation of the minterms of 1, 3, 5, 6, 7, 13, 14. Add to that the don't care, which is 8, 10, and 12. Eight, 10, and 12. Again, it's a 4-variable K-map. A, B, C, D. 0, 0, 0, 1, 1, 1, 1, 0. 0, 0, 0, 1, 1, 1, 1, 0. I like to label the locations again, makes it easy on me. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And let's put the numbers in them. We have a 1 at 1, at 3, at 5, at 6, at 7, 13, and 14. Where's 14? So right now, if I don't have the don't care, I'll take the group of 4 here. I'll take these 2 and these 2. If I don't have the don't care. Group of 4, group of 2, group of 2. Well, let's see what the don't care going to do for me. I got the don't care at 8. Where's the 8? Right here. At 10. And 12. Where's the 12? The rest of them are zeros. I can take these 4. That's a good start. And that's what? A naught. Is it D?
C. Oh, D. Yeah, you're right.
D, right?
Yes.
I'm grouping the ones. What else now? I got a 1 here, I got a 1 there. I got to include, I got 2 ones here.
Could you group the 4 like bottom 2 and 12 and 8?
Here,
14, 10, and 12 and 8.
14,
14, 10, and
14, 10.
12 and 8.
Notice I can take this, but if you did that, you still got to group this one. So the problem with that, yeah, fine, I can group this, but now I still have that one. So you just add this term, this one, and you got to deal with that one. So probably not the best move here. How about if I take these two? I can't, if you add this, if you make that a 1, that's not going to make it better for me. It's going to make it worse, actually. So by taking the 1 here, that will give me what? B, C, D bar. Now, this one you can have 2 different answers to this problem. It should say 2 solutions possible to this. Does it say 2 solution? Yes. It says 2 solutions. Why 2? Because to take the 1 here, to group this one, I can group it with this, or I can group it with this one. Right? I can change that 1 to a 0, that don't care to 1, and group it that way, or I can take it with this. It's up to me. So if I group it this way, I'll have what? A, B, and C naught. If I do it this way, I'll have what? B, C naught, D. So it really doesn't matter. So this will be what? B, C naught, D. Or again, I can go with that one. Notice if I'm looking to group the zeros now, I will make all of these zeros that don't care. Because if I make them zeros, what happens?
C, D. C plus D.
You got C plus D. But you see, you get that 0 there.
You can use the corners.
Yeah, 4.
Yep, I can take the 4 corners, and that will group this, 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 and that. If I group that, I get 4 corners. Notice B is 0, that's good. And D is 0, that's good.
Maybe last column.
I can do the last column. And that'll be A naught plus B. Still get that 0 here. So I gotta take it. I'll take it with this one. And that will be what? Looks like A naught plus C naught plus D naught. Again, that looks like it's smaller design than this one. Less gates. Here's the problem. It looks like small. Why did we group this one? Because we have the zeros here, right? We have to find a way to group them. Why do you group this? Because we have the zeros here. Yep, we have to. There's no other way to escape that. I need that 0. Yeah, the 4. Yep. I'm looking to see if there's any other way I could eliminate one of these. Sometimes like, oh, if I did this, this, and that, instead of making these zeros, if I make them ones, maybe I can eliminate something. But it doesn't look like. If I didn't have that 0 here, I would never take in the top if I didn't have that 0. If that was x, because I would take this, and that would give me that zeros. I don't care about this. Take these guys, that will take care of that and this one. But that 0 forced me to take that row. There's nothing in the bottom that will solve that problem for me. So I'm stuck with that one. Let's try another one. So we turn the don't care to either 1 or 0. It depends what you group in. Do they help you or not? This could have a lot more than 2 solutions. Anytime you have a lot of don't care, it's possible to have more than one option. So the minterms here are 3, 8, 10, 13, 15, plus the don't care at 0, 2, 5, 7, 11, 12, and 14. The fact I have a lot of them, just a little hint that tells me I could actually have a lot of choices here. Again, in case you forgot, location-wise, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I like writing these numbers. It makes it easy on me when I go to put the values. I don't have to count them in my head. I have a value of 1 at 3, at 8, at 10, 13, and 15. There's the ones. So right now, without the don't care, I can take these guys together. I can take this with that. And this one, there's nothing to group them with. Maybe the don't care will help me. 0, 2, 5, 7, 11, 12, and 14. Now again, your focus should be on the ones. I need to group the ones. I can see quickly there's more than one way. Notice these 2 ones here. See them? I can take them as a group of 4 this way or a group of 4 that way. See that? Group of 4 this way or a group of 4 this way. So right now I have two choices for that one. So if I do them this way, that means I'm making these ones ones. That would be what? B and D. How about if I take these 2 with these 2? That's a group of 4. I cover this and that. So if I do that, that'll give me what? B bar, C. I still have one more 1 to deal with.
We can do 10 and 8.
10 and 8. Where's 10 and 8?
And then group 3 are.
Where's 10, 8 and 10? 8 and 10?
And instead
10.
of group of 4s, we could do 3 and 11 and 10 and 8.
You mean like this?
No, not those.
Oh, these 4 with these 2?
No, just 2.
Well, 4 is better than 2,
Oh.
right? So I can do the corners like this, right? This with this. That's 4 corners. That covers that one. That takes care of that one. That's B bar. Is it D bar? Yep. So basically the ones inside the circle, I'm making them 1. The rest of them I'm making what? Zeros. Remember, I have a 0 here. I have a 0 here, 0 here, 0 here. Notice if I want to group the zeros now,
4, 6, 1.
I can take this group together. And that'll give me what? A plus B naught. I'm grouping the zeros. I got a 0 here, I got a 0 there.
Do the adjacent and opposite sides of them together.
This with this. That's the only way I can group them. And if I group them that way, that's what? B is 0
B plus C plus D.
plus C plus D bar. 2 ORs, 1 AND. This is 3 AND, 1 OR. In this case, this actually smaller design.
But you don't have the A at all in the first one.
First one,
Yeah, the sum product.
I don't have which one?
It's, you got rid of the A entirely,
Yep.
so it's just 3 inputs.
Well, this is 2 input, 2 input, 2 input. Yep, correct. But I still have just number of, if you look at just, this is 3 AND gates and 1 OR. I'm just counting that way. Chip-wise, really doesn't make a difference. 3 versus 2. Because if I need 3 OR, and this is 2, right? My chip comes with 4 on it. We'll go back to the lab today. If you get 4, doesn't matter if you're using all 4 or 2. Still going to be the same chip on the board. But what will happen here, has 4 OR gates on it. I'll take A and B bar, and that'll be going to 1. I still got 3 more on that chip. So I'll take B and C, take the result, feed it to this, feed it to D bar, and I'll get the other gate out of it. Still have 1 empty spot on it. Same thing with this. You got 3 AND gates. You're going to be using 3 AND gates in 1 OR. Three AND gates in 1 OR, so you can get 2 chips. One for now. Again, I got to AND these guys together for me. So this chip has, this is an OR gate chip. That's an AND gate chip. So I need 2 chips. The same thing right here, assuming we have the complement. I had a couple more here. Try and see what will happen. I'm hoping one of them will lead us to the lab today. Will give us a nice expression to build in the lab. There we go. F of A, comma B, comma C, comma D. I'm going to do this. Product. I'm changing on you now. What does that mean? Product of M.
Those are 0.
That's where the zeros are. Zero, 1, 3, and 15. Plus, we have don't care where at 2, 5, 7, and 8. Okay, we're gonna have zeros. Let me label them again so I don't have to keep hunting for them. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We're gonna have a 0 at 0, at 1, at 3, at 15. We're going to have a don't care at 2, at 5, 7, 8. The rest are ones. So let's read this. My first reaction was to grab these two with these two, which is 4. Then I said, maybe I should do these. But if I do these, I can go with these 4. So it wasn't good. So maybe I'll go with my first reaction. And that is grab these. And that'll give me what? B, D naught. What do we have here? A, B naught. And now we take care of this one. What do you think?
Can we do a group of 4?
You mean right here? Sure we can. And that'll be what? A, C naught. Again, if you try to group the zeros I see there's a group of zeros, which is what? A plus B. I need that 0. Well, I can't do groups of 4, but I can do groups of 2. And that'll give me B naught, C naught, D naught. Okay, let's simplify this problem. Ready? I'm going to give you the expression and I ask you to simplify it. Instead of just writing it that way, bless you. Bless you. Let me just, I'll work the problem backward. Let me just set this one up. This could be my lab today. Let me label them. F of A plus B plus C is equal to the summation of the minterms is going to be 3, 5, 7, 11, 12, 15, plus the don't care, don't care at 13, 14, and 15. And I forgot to add also,
You already have 15.
I do?
As a mentor.
Okay, 13, 14, we'll do 13, 14, and 8 and 2. Did I use 2? No, 2 and 8. I should put them nicer way. Let's see if I planned it the way I want it, because this might be my lab today. So let's put in the values. 1, 5, 7, 11, 12, 15. Don't care at 2, 8, 13, 14. The rest of them are zeros. So this is my lab for today. Ready for this? Design using only NAND gates. And if I have time, NAND gates. I might come back and say, you know what, let's try it also with only NOR gates. Do it twice. Only NAND, the first part. Part 2, only NOR gates. That's it. Well, let's read that. For NAND, that means I have to get what? The sum of product. So let me get the sum of product.
Question, is there any difference with, it says it's f of a plus b plus c, is that?
Plus D.
Commas?
Oh, A, B, C, D, yep, the 4. I'm just saying I'm used for a variable, call them A, B, C, D. Yeah. So to group the ones, I notice I can group this. And that'll give me what? CD. Group this. That'll take care of the one on the top. 4 is better than 2. Because you could group that right there, the 2, right? But this way is 4. And that gives me what?
AB.
AB. Now I need this 1 here. Group of 4 again. And that'll give me what? B, D. Let me build that using NOR gates only, NAND gates only. And I'll come back and do part B. So this might be our lab today. I think it will be. Because I'm trying to minimize the number of chips on the board. I don't want to use that many chips. So here we go. My design looks like this. I got C and D with AND gate. I made sure there is no actually. And I got A and B with AND gate. And I got B and D. And all these are what? OR together. I said, I want to design this using NAND gates only. None of these are NAND. So how do we convert the AND to NAND?
Make the OR gate, right?
Double complement each one, right? And if you have an OR gate with the input, that's De Morgan's theorem. Remember, A, B naught, that's an AND gate. It's equal to what? A naught plus B naught. You take an OR gate with both inputs complemented, you end up with an AND gate. So this is actually a NAND gate. So now I got 4 NAND gates. I got a problem actually. Well, I got to use 2 chips here in the class. In the design. I do have a chip that has 4 NAND gates on one chip for 2 inputs. But I need how many? I need one that has 3 inputs on it, or 2 inputs. So I am in trouble, so I got to use 2 sets of chips on that one. But at least there's no NOT. I try to make sure there's no NOT, because I knew if I had NOT gates, that would be another chip, and you'll see with these 2 chips, just to power them alone, it's not going to be easy. So make sure you write that stuff. That's what we're doing in the lab. And I got to play with the switches, and I should see a 1, based on the ones I made 1 here, I should see a 1 when I do it where? Because I'm making these ones. So when I run that, I should see the light goes on if my inputs are what? This is the light, LED lid there. If I have this, this, and this one. So it'll be what? 3, 5, 7. If you put 3, 5, 7, 11, 12, 13, 14, and 15. If you put any of these inputs, 3, 5, 7, 11, 12, 13, 14, 15. If you do any of these input, you should see that light goes on. Otherwise, it should be off. Let's design it using the NOR gate. See if that's a little bit easier.
Would it be 2 and 8 as well?
2 and 8, where's the 2?
Well,
I didn't use the 2, right?
yeah,
Or the 8. So these basically, I'm making them zeros.
just anything that's circled, right?
Yep, the ones that circle you want. So I'm making that one that don't care a 1, I'm making that one a 0. Because if I make it a 1, I got to include that. That adds one more piece to my design. I don't want to add one more piece to my design.
Gotcha.
Let's look at the 0. A 0, I see 4 zeros quickly right here. Notice I'm making that one a 0. I can take this with this. I have 2 zeros on the bottom.
Do the column or whole row.
I can take the whole row. I could do this. I can take the 4 corners if I want to, right?
Why would you do that then?
It's the same, just different way. So more than one way of doing it. So because that's still
So you
4.
include 2 zeros if you do it in a row.
Well, I still gonna use that 0 with that 0 anyway, unless I use it with this one. See, my plan is to use that 0 actually this way too. So that 0 is still floating here. So I have 2 options. I can take the whole row or the corners. That will cover it either way. So if you want to take the whole thing, you could. So for the max terms, let's see. For the product of sum, the 4 here, which will be what? A plus D. That's these 2 with these 2. These 2 with these 2. How about these 2 here? That's B plus C. And if I take the bottom layer,
C plus B.
see if I take the bottom layer, what are you going to have? C naught, right? So I already need a NOT gate. So maybe I shouldn't do that. Maybe I should grab the corners. Because that forced me to use a chip, an extra chip for the NOT gate. But what about if I take this, with this, with this, and with that one?
B plus D.
That's B plus D, and I don't have to use that extra chip for the NOT gate.
You win this round.
Yep. Lucked out there. So again, if I want to design this using NOR gates only, because I said design this using NOR gates, well, we begin with OR gates. I was trying to avoid the NOT because I know that adds another chip to my design. It really doesn't matter. You know why? Because only one of them, and I'm going to have an extra gate here. I mean, an extra input to that gate. And you can make a NOT gate out of an OR gate. So a NOT gate, you can create that out of an OR gate by taking a NOR gate or a NAND gate, either way, and tying both inputs together. Since I have an extra one still left there, so I really didn't add an extra chip. Remember how in the previous one, like if I group the bottom 4, I'm going to have a NOT gate. I can use the 4th gate that's left on that chip to make the NOT gate for me. So it didn't really add to the design. So again, double complement that. Now you have an AND here. I mean a NOR, not NAND, sorry. So that didn't change anything. I still need 2 sets of chips. The chip has 4 on it. So even if I group the bottom where I needed the NOT, I still have 1 extra 2 input NOR gate on that chip. I can use it to make a NOT gate for me without adding an extra chip. So I really didn't simplify the design. The only thing I added more wires, less wires, you know. I don't have to connect these 2 inputs together and take the result and feed it there, plus the delay too. And again, this will have a value of 0. The lights are off. When what? Where's my K-map? Here we go. When it's 0, 2, 4, 6, 8, 10, and is it 14, the last one? No, let me see. Let's make sure I add them 4, not 14. Not the 14. 0, 2, 8 and 10, I got them covered. 0, 2, 4 and 6. 4 and 6, I got them covered. What was the last one I used? 0, 1, 8 and 9. 1 and 9. I forgot the 1 and 9. 0, 2, 4. No. I want it to be 0 here. 0, 4, 0, 1, 1 and 9. Yep. I forgot the 1 and 9. I want it to be 0 here, 0 here, 0 here, 0 here, 0, 0, 0. So it should be off here, the 0, 2, 8, and 9. That's my group. It should be off with these 2 here, which is 0, 4, 2, and 6. I have the 2 and 6. It should be off with 0, 1, 8, and 9, 0, 1. Where's the 1? 1, 8, and 9. Yep. That'll give me a 0. Otherwise, that'll give me a 1. The light will be on. Okay. So let's take this design with us. Let's go marching into the lab.